Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the periodic properties within a period. In our last 3 lessons, we learned about the periodic properties within a group. Last time, we discussed the electronegativity and atomic radius of elements within a group. We learned that electronegativity is the ability of an atom in a molecule to attract the shared electrons in the chemical bond. We learned that metals tend to lose their electrons and form positive ions. That is why they are known as electropositive elements. We also learned that as we move down any group on the periodic table, the metallic character of elements increases. In today's lesson, we will explain the general trends of nuclear charge and atomic radius of elements across a period of the periodic table. Students, as you know, we learned about nuclear charge and atomic radius several lessons back. Do you remember what each of these terms mean? Please do your best to define them, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. I am certain you had no trouble with this activity. Nuclear charge is the total positive charge in the nucleus of an atom. An element's atomic radius depends mostly on the number of shells that element has. However, it is typically the distance from the nucleus of an atom to the boundary of the surrounding cloud of electrons. If those were your answers, great work. Students, please look at the periodic table of elements. I am sure you already know the periods in the table are the horizontal rows, moving from left to right across the table. As we move to the right across a period, you will see that the number of valence electrons in each element has increased. However, in any given period, the number of energy levels or main shells remains the same. Electrons fill the same energy level until stable noble gas configuration is achieved. The extra electrons from lithium to neon are added to the second shell. A helpful tip to remember is that the period number is equal to the number of energy levels being filled. Students, why do you think the noble gas configuration is especially stable? Please explain your answer now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to explain why the noble gas configuration is especially stable? The noble gases are stable because they have stable octets of electrons, except for helium, which has a stable duplet. Therefore, the noble gases do not need to attract or lose any of their electrons. Also, since noble gases have shells that are all filled up, the nucleus of the atom is much more magnetically attracted to the electrons. Therefore, it is more difficult to make noble gases lose their electrons. This makes them very stable. This table shows the atomic number, the electron configuration, and the number of shells for period 2 elements. The atomic number is the number of protons found in the nucleus of one atom of an element. It also represents the number of electrons an atom has when the atom is neutral. Electron configuration is the arrangement of electrons in an atom. A shell is an orbit filled by electrons. Lithium, for example, has an atomic number of 3. It has 2 orbital levels and 3 electrons. Carbon has an atomic number of 6. It has 2 orbital levels and 6 electrons. If we look from the left of the periodic table to the right, the nuclear charge, or atomic number, progressively increases. As you can see, the atomic number increases by 1 for every succeeding element. However, it is also important to note that there is an increasing number of valence electrons being added to the same shell. As a result, there is an increase in the effective nuclear charge. Students, please copy these 3 questions onto a piece of paper. In a moment, you will see 3 sets of possible answers to each. Please decide which answer is correct for each question.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, everyone. Let us answer these questions together. For the first question, metals are found on the left side of the periodic table. For the second question, the atomic numbers increase as we move from the left to right in a period on the periodic table. For the final question, for each succeeding element on the periodic table, an increasing number of valence electrons are added to the same shell. In today's lesson, we learned about general trends in the nuclear charge and atomic radius of elements across a period of the periodic table. We learned that as we move across a period from left to right, the number of valence electrons each element has increases. We learned that in a given period, the number of energy levels, or main shells, remains the same. Electrons fill the same energy level until they reach stability. We also learned that if we move across a period from left to right, the atomic number increases. There is also an increased number of valence electrons being added to the shell. Therefore, there is an increase in the effective nuclear charge. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.